So we're going to solve absolute value equations, which means we need to know what an absolute value actually is. And we actually had some absolute value symbols on like the first worksheet or the second worksheet I gave you. I think it was 1.2. And a couple people asked me about them. But the definition is an absolute value is the distance from zero, or the distance from the center. And we always talk about distance as being positive. We never talk about negative distance. So we don't talk about like going negative 90 miles down south, to get to Chicago. We don't talk about distance as negative. And the same thing with numbers and the number line. When we talk about distance from zero, we're talking about the absolute value. Just how far is it from zero? So absolute values, when you think about that distance and you say, okay, the absolute value or the distance from zero is 6, there are two possible numbers that can fit that definition. Positive 6 or negative 6. They're both a distance of 6 from 0. And that's what happens when we solve absolute value equations. We end up getting 2, sometimes 1, sometimes 0, but usually 2 answers because we have 2 distances that would satisfy that equation. Okay? So if you write anything down, all you really need to write down is absolute value, distance from 0. You don't have to draw these lovely graphics. Some of your teachers that you've had in the past might have called absolute value symbols like happy sticks because they're always positive. Yeah. Okay. Moving on. So solving absolute value equations is what we're going to start with. And this here is the general format for an absolute value equation. We have some sort of algebraic expression, ax plus b, inside the absolute values, and then we have that equal to a constant, c. To solve it, we do this part. We split it up into 2 different things because what we're saying is that ax plus b, what's inside the absolute values, could be just equal to a positive c, or that ax plus b could be equal to a negative c. Those are the 2 options. Right? Thinking about, again, that distance from 0, there's always 2 options as far as how that distance is. So let's take a look at a really basic example. The algebraic expression inside my absolute value here is just x. So I say the absolute value of x is equal to 4. What could x equal? 4 and negative 4. X could equal 4, and x could equal negative 4. Those are the 2 things that would make this true. And if you look at our that general format, that's what we did. We took what was inside the absolute value and made it equal to c. Then we took what's inside the absolute value and made it equal to negative c. So the next example, I've got negative 2x is my algebraic expression, and that is equal to 32. And so I say to myself, okay, here are my 2 options. Negative 2x, that whole thing could equal 32, because the absolute value of 32 is 32. And negative 2x could equal a negative 32, because if I plugged in negative 32 into those absolute values, the absolute value of negative 32 is 32. So those are my 2 options. Notice that I don't change what was inside the absolute value. I only make that c value opposite in the second equation. And then from here I can solve. Divide things by negative 2. And I get x here is equal to negative 16. And x here is equal to a positive 16. Now, a common mistake that people will make after I show them examples like this is they're like, well, it's always just opposites. It's just a number and its opposite. It's just 4 and negative 4, or 16 and negative 16. And that's not true. It's not always just going to be opposites. This just happens to be because of the expression that was in the inside. The only thing that was happening here was multiplying, so that's why it ended up being opposites. But let's take a look at an example where it's not opposites. the absolute value of x minus 6 is equal to 6. So here I have the absolute value of x minus 6 is equal to 6. So I could say that one possibility is that x minus 6 could just equal 6. And the other possibility is that x minus 6 could equal a negative 6. Those are the two things that could happen. So I'm going to go ahead and solve these. If I add 6 to both sides here, I'm going to get x is equal to 12. Here, if I add 6 to both sides, I'm going to get x is equal to 0. So anytime you end up having adding or subtracting inside those absolute value symbols, you won't get those opposite answers. So it's really important to then split that up into two equations. Remember that once you split it up into two equations, you're dropping those absolute value symbols because you're actually doing the definition there. Questions you have? Wonderful. How about the next one? What do you notice about this next problem that's a little different than the last two?
We have -2 outside the absolute value.
Yeah, if you were a guessing man, what would you say you'd do with that -2?
Add it on to there.
Yeah, well, not after, but we want to do that first, actually. We want to undo this first because I need those absolute value symbols to be alone before I can split it up. So I'm going to take this -2 and I'm going to add it to both sides of the equation first. So I'm going to get all my constants to the other side so that now I have 4x minus 5, or the absolute value of 4x minus 5 is equal to 15. It's important that you don't drop your symbols before you get them alone. Okay, so now that I have this point, now I can drop my absolute value symbols and rewrite this as two equations. 4x minus 15 could equal 15. And 4x minus 15 could equal, not 15, 5. Minus 5 could equal a negative 15. And from here, I can go ahead and solve. So I'm going to add 5 to both sides. Here on this side, I have a fraction, negative 10 fourths. Make sure you simplify that as much as you can. Negative 5 halves. And so these are my two solutions. X equals 5 and x equals negative 5 halves. And if you were to plug both of these back in, you would find that they are both solutions to this equation. Okay? If I plug in 5, I'll get 20 minus 5, which is 15. Absolute value of 15 is 15. If I plug in negative 5 halves, negative 5 halves is going to give me negative 10. Negative 10 minus 15 is going to give me negative 15. And then the absolute value of 15, negative 15 is 15. So both of those will work. So there's one other situation that I want to show you before we do absolute value inequalities that's important to know about absolute value equations. So this absolute value in equation has no solution. How do I know just by looking at the equation?
Because absolute value can't be negative.
That's right. Absolute values can't be negative. So if you have an absolute value when you get it alone and it's equal to a negative, that's no solution. Be careful because sometimes, it starts out where it's like the absolute value of 2x plus 5 divided by negative 3 is equal to 5. Okay? And you're like, oh, well, that's not equal to a negative. But when I undo this dividing by negative 3 and I multiply both sides by negative 3, Now I have the absolute value of 2x plus 5 is equal to a negative 15. And that's no solution. I can't break that up. Okay? So that's just an important thing to note about absolute value equations. The same does not hold true for inequalities. You have to use a little bit more logic when it comes to inequalities, although I'm not going to put a ton of problems on there with inequality equal to a negative. But and the inequality has more to do with greater than, less than, and what are the range of values in there. Okay. Any questions on that at home or here? So absolute value inequalities are actually super, super useful. They're used in business, manufacturing, all kinds of things all the time because we're talking about parameters of something, okay? And having something that's within a certain parameter or a tolerance. And we have two different situations. We have one where you have the absolute value of a expression is actually less than C, and that means that it's between, they want it to be C units away from the center. So it's got to be between two values. Okay. This would be a situation where, like, I'm making, or I don't know, something, I don't know, I'm filling up bags of chips, and I want the bags of chips to have 12 ounces of chips every time. Well, it's not going to be exactly 12 ounces of chips probably, but I want it to be within a certain tolerance. I don't want one to have 12 and then the other one to have 24. Okay. So that's talking about that tolerance here, meaning within a range. The second type is when you have an absolute value that's greater than C. And that's more of the fact that you're more than C units away from something. Okay? So I want it to be beyond that. And that's more about rejection more than anything. So the way that you remember here for solving is that when you have a less than absolute value inequality, you have an and. And when you have a greater than, and I think greater than, I have an or. And that's literally how I remember which one is which. I think to myself, greater or compound inequality. Less than must be the other one, so it's an and. Okay? So I'll give you a moment to write that down. Okay, everybody got this down? Let's rock and roll. Let's take a look at two examples. I have the absolute value of 2 is greater than 4. So this is a greater than, less than. The absolute value of x plus 2 is less than 4. So this is a less than. That's my and compound inequality. So when I rewrite this, what I do is I actually just rewrite the x plus 2 is less than 4. And then I put the same symbol in the front and then the opposite of my C value. And that becomes my and compound inequality. Okay? Because what I'm saying is I want this value to be, the absolute value has to be less than 4, which means it has to be between negative 4 and positive 4, that value. It was inside the absolute value. From there, I can go ahead and solve.